In this video, we shall learn about ocean currents. Now, what are ocean currents? Well, they are streams of water moving along the surface of the ocean in a definite path. Such more or less permanent streams of water which flow in a definite direction are known as ocean currents. Ocean currents are like rivers in the ocean, thousands of kilometers in length and sometimes about 200 kilometers wide. Based on temperature, ocean currents can be broadly divided into two categories, that is, warm currents and cold currents. Warm currents are those currents which flow from the lower latitude in tropical zones towards the high latitudes in the temperate and the subpolar zones. That is, they move from equator towards the poles and they bring the warm water into the cold water area. When it is cold currents, they have a lower surface temperature and bring cold water into warm water areas. These currents flow in the high latitudes from the polar region towards the lower latitudes, that is towards the equatorial region. Then, based on their depth, the ocean currents can be divided into two categories, and that is surface currents and deep water currents. Surface currents constitute about 10% of all the water in the ocean and lie at the upper 400 meters of the ocean. Deep water currents make up the other 90% of the ocean water. These waters move around the ocean basin due to variations in the density and gravity. Deep waters sink into the deep ocean basins at high latitudes where the temperatures are cold enough to cause the density to increase. Let us study the causes of ocean currents. Well, the causes of ocean currents are level of salinity, temperature, Earth's rotation, land, and the planetary winds. So, if we see the level of salinity, when I say level of salinity, it means the amount of salt present in the water. Salinity of the sea is generally affected by the inflow of fresh water from the rivers, melting ice, and rainfall, and by evaporation. For example, a high rate of evaporation in the Mediterranean Sea increases the salinity and therefore the density also increases. As a result, the currents of less dense, that is, less salt water flow into the Mediterranean Sea from the Atlantic and the Black Sea. Smaller countercurrents of a higher density or salinity flow outward, but that would be beneath these currents, so that the salt content of the basin remains constant. Next one is the temperature. The temperatures are higher at the equator than the poles. Hence, the water in the ocean near the equatorial region is heated more than that near the poles. This unequal heating sets up convectional currents in the ocean. The warm waters of the equatorial region are light and move along the surface towards the polar region, where they are cooled. The cold water is dense and heavy. It sinks downwards from the surface and moves slowly towards the equator, where on warming up, it may rise to the surface again. Next one is the Earth's rotation. The Earth rotates from west to east. First of all, the speed of rotation of the Earth is maximum at the equator. That is around 1600 kilometers per hour. So all moving bodies, that is winds and ocean currents, move in a clockwise direction in the northern hemisphere and anti-clockwise direction in the southern hemisphere. For example, if we take up the Canary and the Gulf Stream in the northern hemisphere, they are moving clockwise, whereas the Brazilian and the Benguela current, if you look at, they are moving anti-clockwise direction. Next one is the planetary winds. Now, planetary winds also play a dominant role on the flow of ocean currents. Now the names of the winds are trade winds, westerlies, and the monsoon winds. Trade winds blow between the equator and the tropics. These winds move equatorial waters polewards and westward. They warm the eastern coast of the continent. For example, the north equatorial current warm up the eastern coast of North America as the Gulf Stream, and the south equatorial current warms up the eastern coast of Brazil as the warm Brazilian current. Then it is westerlies. Now westerlies blow in the temperate latitudes and result in the northeasterly flow of water in the northern hemisphere and the opposite in the southern hemisphere. The westerlies force the warm Gulf Stream to the western coast of Europe as the North Atlantic drift. They cause the cold west wind drift to flow towards the equator as the Peru current along the South America and the Benguela current along South Africa. Next one, the monsoon winds. The strongest influence of the prevailing winds on the flow of current is seen in the North Indian Ocean. Due to the monsoon winds, the direction of the currents change from southwest in summer to the northeast in winter. Because over India, these are the two main winds, that is southwest monsoon winds and northeast monsoon winds. Next one is the land. A landmass obstructs the flow of water of an ocean current and diverts its movement. For example, at Cape Sao Rock, the south equatorial current gets divided into two branches. One joins the north equatorial current and the other becomes the Brazilian current.